Hello friends, today we will see mill contour, and in mill contour we have so many subtype operation to perform 3-axis programming. So my first operation is this cavity mill. We use cavity mill to create a roughing operation for any part. So, so cavity mill operation is used to remove large amount of material. That's why we are uh, asking this as a roughing operation, and we use different type of tool to remove this material. Most of the time we use anvil, tip radius tool. These type of tool will use for roughing operation, and we cut so many type of parts like dies, cavity, casting and forging component. In this operation, our tool direction is always in Z direction, means it is a fixed direction operation. Because it is 3-axis operation, so the tool direction will be in Z direction. So let's discuss this with an example. So here I am selecting this, and before this I am going to create one new workpiece. So click this geometry, click here, and MCS, and click here. So work for one workpiece one, first define the part. This is the part, and click here to define the blank, and I am going to use bounding block for this. Okay, don't display this. Okay, now we need a tool, so you can retrieve tool from the library or you can define your own. Click here, and here we have, this is the tool, right? And if you see this tool, and here in, okay, no problem. So I'm going to use this tool, right? 50 animal with 6 radius. Okay, cancel it. Now create the operation and select this cavity mill, and here my location is, and the tool, and workpiece 1 is my geometry, and this method is rough, and okay, right? And here see the tool is defined, and my cut pattern is follow part, and step over is 70%. If you want to reduce, you can reduce it, and the depth of cut I'm using 1, and click here. For if we have multiple pocket like this and this, so we can cut in two ways, like depth first. So first it will remove the material from first pocket, then it will cut the second pocket, that is depth base. And if you want to cut both pocket at the same time, means it will cut first cut here, and then first cut in second pocket, the second cut in second pocket, and second cut in first pocket. So like this it will work. So here I am selecting depth first, and for coolant and containment, I'm not going to use containment. By default it is none, so keep it none. This will come in upcoming lecture. And from geometry, see the cutting area. If you are using cavity mill and you are not going to select any cutting area, it means you are selecting the whole component, whole part will select automatically. And here the stock, part stock, how much you want the stock. So I'm just using 0.75 as a stock, and generate. Okay, say this is the tool path. Tool cannot cut some areas because of bigger dia, and click here, see, and see the verification. This is most important option for roughing. Now see, this is the result, and the amount which is left on the walls and the floor is 0.7, right? And some areas are ignored because of bigger tool, because the smaller tool cannot, because bigger tool cannot cut in a small area, so that area is ignored. Otherwise, it has removed all the material. And come to this cut level. Here you can see the range is automatically, the range means if you will expand this list, here you will find some level. This is the first level. Click. The second level is this yellow, this white one, and this third is something here, this one, right? So first level is this, second level is this, and third level is this. So it will automatically creates the level with respect to planar face, right? So if you want to make some changes, like I just want to cut up to a, see this, click here, and the total depth is 108, and first is 30, 27, and 46, and again 50. See, this is plain somewhere else here, right? This one, and for fifth one, this is the fifth. Because of planar face, it is creating the label. And see here, this is here, click here, right? So this is the bottom. Now, if I just want to cut up to this, right? So remove this one. So bottom limit is 98. So it will remove material up to 98. Generate this again, and wait. I will show you the result. Because of a smaller tool, it is a bigger tool. It is not possible to cut up to this limit. So I'm going to change this limit. Remove all these, right? And now I'm adding one more limit, and this limit is up to 45. See, here is the limit. If you will generate, now we will create, we will find the tool path up to this 45 from the top. Okay, if you want to check, click here and see, the tool path is up to 45 from the top. Okay, and if you want to restore it, so click this automatically, and again it will generate all the limits. If you will generate, toolpath will again generate. So hope you understand this cavity mill. Rest option we will see in next lecture. Thank you for watching. Hello friends, in this lecture we will see cavity mill, and this is the second lecture on cavity mill. So I have this part, and now I need a workpiece. So first of all, create a workpiece, and if you will see, MCS is here. Now under this MCS I'm going to create one more workpiece, and this workpiece, this is a geometry and blank. For blank I'm using bounding block. Okay, and okay, right. And for tool, click here, and I'm going to create one more tool, animal 40, length 60, right? Okay, 40, okay, 125. See the length. If you want to check the length, you just drag this or click the lower face. This will come. See, the tool is still small, so I'm using 160, right? Now it is okay. And I want the holder, so click here, holder, and come to library and select a large compression holder, and okay, right. Now the tool is defined, and if you are, see, we have some more tool for rest of the operation, but here I'm not going to do any further operation. So double click here and add a lower radius tool. Okay, so this is my working tool. Click here. Now select the cavity mill, click here, and from mill contour I am using this cavity mill. So program is my folder, and the tool is this one. The last one is my tool. Click, and the workpiece is this workpiece one, and rough. The operation is rough. Now see, the tool is defined, and here I am using follow part, and the step over I am using 40%, and the depth of cut for this I am using 8. Now come to geometry. In last cavity mill operation we have not selected any cutting geometry, but this time I'm going to select the cutting area. So click here and change to tangential face and select. So all the tangential face will select, and it will cut all these face which we have selected. If you want to skip some area, you can also select this trim stock for trim, so that we will see later. So click here for cutting. Automatically it is creating the label. Now generate, the toolpath will generate. Okay, let's see. So this is roughing operation. Okay, and again okay. Now copy this operation and paste inside. Double click here and come to this geometry, and in this geometry I am going to specify trim boundary. So click here. With the help of this curve I am using tangential curve, and select all the curve. This curve is not properly, so remove it and just create a boundary with the help of sketcher, or for now I'm just using inner curve. so that I can select it properly and easily. Select this, select. So this curve is selected now, and here is the top face. Okay, generate it. Trim boundary is not properly, so let's go to modeling, and here from sketcher set the top face, and here I'm going to use project curve and select the curve. Select all the boundary curve. Make sure all the curves are connected properly. Right. So this is the boundary curve. Okay, and finish. To check it, I'm just using extrude. If it will extrude, see here it is not properly matched. Right. You can see here. Cancel it and double click here, and again use this project and zoom this area, and here is this single line. Okay, now it is close area. Finish. Now I want to use this curve. Now move to manufacturing, double click here, and for boundary, trim boundary, I'm using this curve and select this connected curve. Right. Okay, now if you will generate this toolpath, the toolpath will skip this area. Say this. Here we can adjust this with the help of different cutting pattern, and see, still this is not properly, it is coming inside, so we need to change it because it is coming here and it will intersect with the part that will come in non-cutting move. So hope you understand. Thank you for watching. Hello friends, in this lecture we will see one more option from cavity mill. So previously we have seen two examples with cavity mill. So this is the third one. So first of all, I'm going to create a workpiece. So double click here and define the part. So this is my part. Select this part. For a blank, I'm using bounding cylinder, right? A cylindrical body will come, and if you want to increase distance, so in Z direction, okay, or you can increase from here also, like 110, bottom it is 0, so it will extend on top side. And same for the dia, 152, so diameter will increase and click OK. And here one more thing, this is my table, picture, clamp, all these things will come under this check because the check tool will not cut any geometry which is defined under this check. So check is for picture, table and clamp, etc. Right now for this I need a tool, so I am creating a tool and diameter 20 and length I am defining flute length as 10, total length with 35 and add a holder, select it, this is the holder, okay, and close. Right now the tool is defined. Now I am going to select this cavity mill, click here, mill contour, and under this mill contour select this and define the tool, rough workpiece and OK. Here tool is defined for a periphery, 50% is a step over and depth of cut I am using 5 for this case so that it will perform a little bit faster. Now come to this geometry and here if you want you can select your geometry, otherwise it will select whole geometry itself. Okay, and the stock is 0.5 and tool axis is Z direction and rest is okay, just generate and let's see the tool path. There is a collision, okay. Now click here and click this, pause on collision and generate. Okay, if I disable it and generate, so tool path will generate for a whole the part, whether it is colliding or not, it will generate. Now it will stop, it will pause when it will creating any collision between the part or the tool or holder. Let's see. Holder and IPW are colliding, right? Now continue, if you want you can continue. So again and again it is doing this, so okay. And here enable it and from tool I am selecting this report shortest tool and generate. Or come to this collision, now generate. Click here. Now okay, right click over this cavity mill and come to this tool path and here we will find this report shortest tool. So collision free shortest tool will be 108, so 110 I am going to use. Click here, double click here and the tool length I want 110, right? For collision free, I need at least this length for collision free. If you want, you can select this right now, no problem, just calculate and it will calculate and check it with this collision setting, pause this and OK and see the result. Okay, so hope you understand this tool path. Okay, hello friends, in this lecture I'll show you how to define trim boundary. In this case, if you will see here, I have a cavity and in this cavity I don't want to cut this area, so we can use trim boundary to avoid this area. So for workpiece, this is the tool and this is the blank which I have already defined, and for this case I am using this one tool and the tool is 30 with 2 radius. Okay, now select this cavity mill. Okay, tool is defined, periphery 50% 1, and from geometry I am selecting this cutting area and this area too. Okay, and if I generate this tool path, let us see the result. It is already done. So why it is just because of this order. Okay, so drag and drop in different location so that the previous IPW will not be visible, and I have used in the same, sorry, this is a mistake again, just delete this one if you don't want, delete, and this is the toolpath. Now this tool will remove all the material on the selected surface with the small pocket also. Right, now I want to assign this rectangle as a trim boundary. So you can see here I have this curve and okay, now generate. If you will see some engage or retract is inside this pocket. So come to this strategy and here in trim behavior I am changing this to follow boundary and generate. Okay, let's see the result now. Or I can use any different cutting pattern for better result. Let me check now. Now it is okay. Okay, come to this strategy. Here we have one more option, a small closed area. So if you select cut, it will cut. If you want to ignore, you can also ignore this. For this one, I'm just removing this trim boundary. Generate the toolpath again. See, the pocket is now cutting. Now let us check this pocket. Click here and object. So this line is 55 and this is 55. Okay. So the size is 55, 56 mm. Double click here, shading on. Come to this strategy and here I am going to ignore this. I want this pocket to be ignored. And the tool dia is 30. So 20% of tool dia it will ignore. If the size is greater than less than 200% of tool dia, it will ignore. So now it is 55 and we are ignoring 60. So definitely this will less than 60. So this pocket will ignore, right, and generate. So in this way also you can ignore this. Okay, okay. So hope you understand this. See you in upcoming lecture. Thank you for watching.